everyone. Today we're going to be exploring space. Hi, my name is Gabriela Melendez. I'm a second year student at the University of Toronto Scarborough, and I'm studying human biology and psychology. As a kid, I've always asked why, and I just was always curious about things happening around me on Earth, in space, wherever, and answers these questions, and that's why I love learning about it. Fun fact about me during quarantine is I've been playing a lot of video games, I've been reading a lot of books, and I've been chatting with my friends over Zoom. Uh, Today, I'm going to be talking to you about space exploration and how to build your own straw rocket. So let's get started. On the agenda today, we have our lesson of space exploration, and then we're going to have our activity. And we're just going to go over materials and then actually build it. So how did we start? Ancient civilizations looked at the night sky and recorded and passed down their knowledge. So they either wrote it down or they told it to their children in stories, and then they passed it on to their children. Down generations and generations, a bunch of people learned this knowledge through stories or through writing. So they looked at the sky, like I'm sure all of us have done at one point in our lives, and saw all the stars and the planets up there, and then they used this knowledge to their advantage. So what did they use this knowledge for? They used it for navigation, timekeeping, and farming. Navigation just means getting from point A to point B. So right now we have GPS, so we could just plug it in and follow where the arrow is going, but they didn't have that at the time. So they used stars. They had the North Star, and based on where they were going, they could tell if they're going north, east, south, or west. Then we have timekeeping. Now we have watches and calendars. They didn't have that at that point. So they used the star to tell what time it was, like the star, our sun, to tell what time it was using a sundial. And they also used the moon to tell how long it has been since a certain point, because a full moon comes once a month. So if someone said, oh yeah, that happened 2 full moons ago, you could be like, oh, that happened 2 months ago. They also used it for farming. They didn't really know what seasons were, right? So they just looked at the stars and the planets, like where they were, to tell what time, what season it was, and whether or not it was time to plant a certain plant for their farm. Isn't that interesting? Next, many years later, maybe a couple hundred years later, 100,000, Galileo improved the telescope and pointed towards the sky and saw clear images of planets and moons. So before, people were just looking at the sky with their eyes, not using anything, and they can just tell there's the big white sphere in the sky, the big white ball. There's some shiny dots in the sky. They can't really see much more than that. So Galileo took a telescope, made it super strong to see things really far away, and he pointed towards the sky, and he can see craters on the moon, which are just like little indentations in the moon. And he also saw planets. He saw Jupiter, and he discovered that it had 4 moons. So now it's called the Galilean moons. In 1961, Russia sent the first man into space. So it was at this point that we realized, oh, we can actually explore space in space, because up to this point, we have just been exploring space from Earth, from our telescopes. And then in 1969, America put the first men on the moon. And then at this point, we can actually go on the moon on a different place that's not Earth and collect things to learn things about it. So this opened up space exploration hugely. So next, who explores space? So the 2 main people we most know of are astronomers and astronauts. This is what most people think of when you think of what is a space scientist? So an astronomer studies planets and stars and galaxies from Earth and collects observations and data about them. So observations are just things you see, and data are numbers that you get from it. So questions like, How many planets are there in our galaxy? How long has the sun been shining for? Are all questions and answers that astronomers explore. So astronauts are pilots for the spaceship, and they also conduct experiments in space. So if you really enjoy math and science in school, these might be the jobs for you because they use this all the time in their job. And then I just included some pictures of some Canadian astronauts. On the left here, we have Chris Hadfield, and on the right, we have Julie Payette, who's also currently our Governor General. Why do we go into space? A main thing of why we do anything is curiosity. The big question of what's out there and what can we learn from it is one of the driving forces of why we go into space. So what's happening on different planets? Also, space experiments, like how is space different than Earth? An experiment they conducted was growing zucchini on space, and they discovered that zucchini grows differently in space as compared to Earth. Another thing is the history of our whole solar system. So where are asteroids and black holes in our galaxy? How did the planets and the stars happen? These are all questions we have, and the only real concrete way of knowing anything is going to space and finding out that information. Also, we get new technology. Going to space is really hard, right? We can't just walk our way into space or else everybody would be doing that. So finding out the solutions to these challenges gives us new technology to use here on Earth. So things such as wireless headphones, our portable laptops, the cameras on the back of our phones. These are all things that have been developed by NASA and other ways to like overcome the challenges of going to space that we use now in our everyday lives. The other thing is that we work with other countries when we're on a mission to space. So we work together with these other countries to share information that we gather. We share experiments and building spacecrafts. We do that all together, such as the International Space Station, which we will talk about next. So, space missions. There's a lot of different ways to observe space once we're up there. So we send things such as satellites, spaceships, we have the International Space Station, we have the Mars rover, and some new interesting developments in space exploration. So let's go over them. We have the satellites. They collect information about space. So satellites just mean that they're orbiting, they're going around a certain thing in space. So they can be going around Earth, they can be going around the sun, or another planet. So the moon actually is a satellite of Earth because it goes around Earth. But the satellites we're talking about today are made by humans, and they're used to collect information about space. So the ones we have that we use on Earth, they take pictures of Earth, and we can take these pictures and we can predict the weather. And we can see the different ways that our weather is changing over time. When we have it going around the sun, we take pictures of the sun, and we use that information. That information goes straight back to Earth, and we can study and find new information from these pictures. Next, we have spaceships. These are the things we think of most when we think about space travel, right? So Apollo 11 brought the first astronauts to the moon. And we'll shortly see some pictures of Apollo 11. Next, we have the International Space Station, also known as the ISS. It's a large spacecraft made by a lot of countries that orbits Earth. So it serves as a home where astronauts live. The space station is also a science laboratory, so they do experiments up there. Several countries work together to build and use the space station. In fact, Canada put the Canada arm on the space station, and you can see that on the $5 bill. And Chris Hadfield, the astronaut I showed you earlier, spent a lot of time on the ISS. Next, we have the Mars rover. It's a robotic vehicle that drives themselves. So the Mars rover has solar panels on itself that takes energy from the sun and uses it to move. A space rover takes pictures, and it also collects samples to analyze and sends this information back to Earth. Next, we have the SpaceX reusing rockets. So this is a really exciting new thing in space exploration, because before, when you send up a rocket and you send up a spaceship, you can only use it once. It'll only go up to space and then it'll come back down. But now, the guy who owns Tesla, Elon Musk, he made a new place called SpaceX, and his employees have found a way to reuse rockets. So they can send the rocket back up, it comes back down, and then it's ready to go for another mission, which saves a lot of money because building all of these rockets is very expensive. So these are the spacecrafts. Up on the top left, we have satellites. So this is what a man-made satellite would look like. And it's just at the edge of Earth, right? Barely in space. And it keeps on going around and around, and you can see how it can take pictures, and it has solar panels on its sides to take energy from the sun so that it can continue going round and round. On the top right, we have Apollo 11, and if we see on the bottom, this is a rocket. So this is the part that has all the fuel and can shoot it up into space. Usually, spaceships have more than one rocket, so the first rocket will launch them really, really far up, but they still need more energy, so they have a second rocket that launched them even further up, and that gets them into space. So really, only the tip of the rocket, the spaceship, goes into space, and that tip has the astronauts in them. In the bottom left, we have the International Space Station, which Chris Hadfield was on for a very long time, and Canada helped build. And then on the bottom right, we have a Mars rover. This one kind of looks like WALL-E, and you can see he's scanning the surface of Mars, taking pictures, and he even has a little hand to take little samples. Okay, so now we're going to have our materials check for our activity. So everyone should get a straw, doesn't matter if it's bendy or straight, some paper, some scissors, some tape, and optionally you can have markers, crayons, or pencil crayons, just so you can decorate your spaceship. If you run into any troubles, you can always ask a parent or a guardian, or even an older sibling to help you. So we are making straw rockets. And when we're going into space to explore space, we need rockets to get us there, right? Because we need a really big amount of energy to lift us into space. So to launch these spacecrafts into space and to use them for space exploration, like I said, we use rockets. But there's something stopping us from just jumping or throwing things into space, right? If I throw something as hard as I can all the way up, it won't just magically show up in space, right? It will come back down. If I jump really hard all the way up, I can't jump into space, right? So why? What's stopping us from just throwing something into space? Answer is gravity. So in order to put our spacecraft into space, we have to give the rocket enough fuel to have enough force to be stronger than gravity. So this is what our experiment's going to show. So let's build our rocket. So we're going to cut a rectangle of paper about 3 by 10 centimeters. Doesn't have to be super exact. So we're going to have our rectangle, and then we're going to fold it in half. And then we're going to tape the sides. So this side, and then this side. And then at this point, you can draw a rocket right on the rectangle, or you can draw it on a separate piece of paper, cut it out, and then tape it on a rectangle. This is what I did. This is my rocket. I don't know if you guys can see it. That's my rocket. So after we do that, after we decorated our rockets if you wanted to, we're going to place the straw, we're going to place the rectangles on the straw loosely. We don't want the straw to touch the very top. We want it in the middle. And then we're going to blow. So we're going to blow here. So my rocket went up and then down. So we can experiment doing this. We can blow the rocket straight up. We can blow it horizontal. We can do a little blow and then a big blow. See what it does and record it down. So what did we learn from our experiments with our straw rocket? There are two forces acting on our straw rocket. Gravity is pulling it down, while the forces from blowing the straw is pushing it up. These two forces combined give it a curved movement. So we saw that our rockets went up and then down. So this is a curve. So going up is the energy, like the force we get from blowing our straw. And then down is from the force of gravity. So a real rocket needs to overcome the gravitational forces downwards. So we saw that even if we blow with all our might, it only goes so far and then it comes down, right? From the ground to space is a really, really long way, right? So if we want to make it all that way, we're going to use a lot of fuel and maybe more than one rocket. So as we saw on Apollo 11, we're going to have different rockets. So we have the main big rocket that gives us for the first push. So it goes up. And then we're going to need another rocket to go even higher. And then maybe just a little nudge and go, whew. And then now we're in space. And then we can cruise using our space shuttle. And then that's how rockets work. And that's how we use them to do space exploration. Thanks so much for watching. If you have any questions or comments, we'd love to hear from you. You can contact us here at this email, or you can visit our webpage. Thanks so much for watching. Bye.